So today we'll discuss the producer consumer problem. Okay, here the producer is the one that produces any contents or data that is required by the consumer. That is, consumer and producers are any other processes just like the regular processes what we did till now, and the consumer is the one who makes utilization of the data that is being produced by the producer. Okay, so there has to be something in common in between the consumer and the producer, and that is the buffer. This buffer is considered to be the shared area in between the producer and the consumer. Now this buffer is divided into 8 slots ranging from 0 to 7, that are a total of n equal to 8. This is being the total number is being denoted by n, which is 8, and every slot is being denoted by buffer of 0, buffer of 1, so till the last number, that is buffer of n minus 1. Now here we'll start with the producer consumer problem. Assuming that the producer produces an item and the consumer consumes an item, so initially dealing with a normal working condition. So here we have a variable called as count. That count is called as a global variable, where the count, to denote a count, we have marked a square box here. Okay, and this is the producer code, and here is a consumer code. So since the count is a global variable, we have been notifying it on both the sides. We have mentioned it on both the sides. Now here the producer wants to produce a code now. So since this is a normal working condition, in a normal working condition, so producer, we come inside the function int item p. This is a variable. While true, the condition always stands true. Producer is producing a item here. What item is it producing now? Item p. And this item p, initially I denote the first item that is being produced by the producer, I denote it as a. So now while count double equal to n, so is the count double equal to n? So initially, do we have any of the items that are being produced by the producer? No. So there are no items that are being produced by the producer, and thus we denote the count as 0. So initially the count is as 0. So is 0 double equal to 8? No, the condition fails. And so the 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 in pointer initially is pointing at the 0 position, and so the buffer of 0 equal to item p. So what is the item that has been produced here? It is a. So this item a, which has been produced by the producer, is being put into buffer of 0. So since the in value is 0, so this item a, item that is a, that is being produced by the producer, is being put into buffer of 0, and so the buffer of 0 value is loaded with the value of a. Once it is loaded with, once the buffer is loaded with the produced item, then the next instruction executes, that is in equal to in plus 1 mod n. What was the initial value of in pointer was pointing at 0th value, so 0 equal to 0 plus 1 mod n. What is n? 8. So 0 plus 1 mod 8. So 0 plus 1 mod 8 is 1. So in value is updated to 1. So the new value of in becomes 1. Now, so once this has been completed, a item has been produced, and since the count is denoting the number of items present in this buffer, so now the next pointer has to be pointed out by the count, since at the next position it has to be stored if at all if any items are being produced, and so the count value has to be updated, and so it comes here. So count equal to count plus 1. So initially the count value was 0, and thus count plus 1, 0 plus 1, so the new value of count is now 1. Okay, so this is the producer producing an item. So the new value that has been, new item that has been produced by the producer is a. So this is a. Okay, and now this item will be utilized by the consumer. So again we run the consumer code. Okay, so now int item c is, c stands for consumer, while true, assuming that this condition is true, while count double equal to 0. Is the count double equal to 0? No, the count is initially 1, because there is an item that is being produced by the producer. So is 1 double equal to 0? No, the condition fails. And so it comes here. Int item C, buffer of out. Out is initially pointing to the 0th position. So out stands for 0. So what is the item that is that is present in buffer of 0? It is A. So item C is loaded with the value of A. So what is the initial value of count? Initial value was 0. So out equal to out plus 1 mod n. Initial value of out was 0. 0 plus 1 mod n. That is out. The new value of out is 1. So this 0 value is updated to 1. And now, so this, since this item has been consumed by the consumer here at this point of time, so this item has to be removed. So since it has been consumed, it should not be present in the buffer, and this item has to be removed. So once this item has to be removed, is what should be the count now? The count should be 0. And now to reduce the count, count equal to count minus 1. What was the initial value of count? It was 1. And now since the item has been produced by the consumer, it is reduced to 1 equal to 1 minus 1, that is 0. The new value of count is 0. And since this value count, this variable count value is reduced to 0, and since this is a global variable, the same has to be reflected here. The same has to be reflected here. And so this is the normal working condition. What happened here was, here the producer produced a problem, produced an item. After he produced an item, that got uploaded to the buffer, and since that was loaded to the buffer, the count value was incremented, and the incremented count value became 1. After which the producer process, the consumer process came, it started executing, and there was an item in the buffer. That item had to be utilized by this consumer, and since that item was being taken by the consumer at this point of time, this item got utilized, and so since this item got utilized, the count had to be reduced to 0 from 1, and this is a normal working condition. Now dealing with the producer consumer problem. Okay, we saw a normal working condition here. Now the case is that, assume that there are already 3 items in the buffer, that is A, B and C. So what should be the count value now? So the count value should be now 3. Okay, and if there are 3 items already in the buffer, so to which position does the in pointer point out now? To the next position. So what is the next position? That is to the 4th position, since there are 3 items, to the 4th position. So what is the value of it? It is buffer of 3, that is in of 3. So this in value is now 3. Okay, assuming that this consumer has not utilized any of the items that are being produced in the buffer. So as of here, since there are 3 items, the out value, since the consumer has not consumed any of them, the out value I will reload it to 0. The out value I will reload it to 0. Okay, now assuming that the producer wants to produce a one new item. Okay, and so it starts producing. It goes as follows. See here. So now producer comes inside, int item p, while true, producer produces an item called as D now. Okay, so producer produces an item called as D. Now while count double equal to n, what is the count value now? The count value is initially equal to 3. N value, n means what? Is the buffer full? No, the buffer is not full. That means 3 is not equal to 8, right? So this condition fails, and so it comes inside. So here buffer of n, at what position is buffer pointing out now? At 3rd position. So buffer of 3 equal to, what is the item produced here? The item produced is D. The item produced is D. So I will update the buffer with item D now. Okay, now what was the in count initially? In count was initially 3. So now it has to point out to the next position, and so in equal to in plus 1 mod n. So in plus 1 is 4. So 4 mod 8 is 4. So the new value of in is now 4. Now, so since there are 4 items produced by the producer and the count has to be updated to 4 now. So to update this count, I will execute this instruction count equal to count plus 1. When I execute this instruction, does it directly get executed? No. In any instructions in a computer system is converted into micro level instructions, and so these are the micro level instructions for incrementing any count. Load rp is a register for a producer. Okay, assume rp is a register for a producer. M of count, what is count value here? The count value is 3. So count value is 3. This count value is loaded into rp. So this got updated to 3 now. Increment rp, so this got incremented to 4. But before this instruction, that is the next instruction I3 gets executed, this program gets preempted. So now the program is preempted. Reasons for preemption are a lot many. The time slice might have got over, then the another higher priority process might have come into picture, whatever may be the reason. So now assuming that this process has got preempted, that is the producer process has got preempted, and thus it is switched to the consumer quota. Okay, so now how many items has the consumer consumed till now? 0. So the pointer is initially pointing out to the 0th position. Now we'll execute this code. We'll try to consume the items one by one. So while true, okay, then while count double equal to 0, what is the value of count now? The value of count is initially equal to 3. Okay, so there are items that are being produced in the buffer, that are already being stored in the buffer. Is it equal to 0? No, it is not equal to 0. So this condition fails. It goes to the next line. Item C, buffer of out. What is the buffer out? What is out value? It is 0. What is the buffer of 0 value? It is A. And so this buffer of A value is given to item C, this variable. Now out equal to out, that is, since this variable has been consumed, this has to be removed from the buffer. Now out equal to out plus 1 mod n. Once this has been consumed, the out value points out to the next pointer, that is the next slot. So it has to point out to 1. Now initially out value was equal to 0. So it is 0 plus 1 mod n. So the new value of out is 1. Now, so this, since this item has been produced, this item has been consumed by the consumer, that has to be removed now. So what should be the updated value of count? 1, 2, as of now it was indicating 3, since it got preempted here. So it should indicate the count value should get updated, right? So count equal to count minus 1. What is the value of count? 3. So 3 minus 1 equal to 2. This has to happen accordingly, but when you execute this instructions as in the micro level form, now see, load of rc comma m of count. What is count value? 3. So the 3 value is loaded to rc, so the value of rc is 3. Okay, now decrement rc, so decrement rc instruction got executed, so this became 2. So before the control executes the next instruction, this got preempted, this got again preempted. So by default, who is another process that is waiting in the cpu to execute? It is the producer code. Now since this producer code has executed till the I2 instructions of the micro level instructions, the PCB is holding the value that it has executed till here, and so this process, the producer process, resumes the execution. It will not start from the first. Now it will resume execution from I2, that it has executed I2. The remaining code has to be executed now. Now what was the value here in rp? The incremented value was present, so this the next instruction gets executed, that is I3. So what is the incremented value of rp now? It is 4. So 4 gets entered into count value. So what is the count value here? It is 4. The count value got incremented to 4. Okay, and thus now after this, who is waiting? So this process completely got executed. So this process got terminated. This process got terminated. Once this process got terminated, then who is the remaining process here? It is the consumer process. Now, what is the updated value of count? Here it was updated as 4. Here it was updated as 4. So before this got updated, okay, but anyways, this got updated as 4, but the value of register, the value of count in the register RC was 2 at this point of time. So now this 2 is being loaded into count. So what happens to the updated value of count now? What value happens to the updated value of count? It becomes 2. Once this process executes, once this instruction executes, this process also terminates. So what is the value of count at the end? It is 2. But how many items are present in the buffer? There are 3. So this is a mismatch. There are 3 items present in the buffer, and there is a value 2 that is being showed in the value of count. So this is a mismatch, and this contributes to a producer consumer problem.